There's all kinds of fun things you can do with functions. You can shift them vertically or horizontally. You can rescale them or reflect them. First, we talk about vertical and horizontal shifts. If we add k to the function f, it's going to shift the graph of f up by k units if k is positive, or down by k units if k is negative. If we change the argument to the function from x to x minus k, then it's going to shift the graph of f by k units to the right if k is positive, and down by the absolute value of k units to the left if k is negative. If we have a base function here, we can think about shifting this downwards by 5 units by subtracting off 5 from the function, and that's using the first rule with k equal minus 5. If we want to shift it to the left, then we would use the second rule and we'd set k to be minus 5 also. And so this would give us y is x plus 5 all squared, and we see that with the red curve. We can rescale by using a constant c in front of f, and this will stretch the graph in the vertical direction. If c is bigger than 1, it'll make it larger in the vertical direction, and if c lies between 0 and 1, it'll compress it. Likewise, if we want to change the graph in the horizontal direction, we put the c inside the argument to the function, and we say f of cx. If c is bigger than 1, this will compress the graph horizontally, and if c is less than 1 but bigger than 0, it'll stretch the graph. If we have a base case here, y is equal sine of x, we can think about increasing the amplitude of this function, and we'd use the first rule for that. And in this case, we choose c is equal to 2. If we want to change the frequency of the function, we go back to the base case, and then we're going to end off using the fourth rule with c is equal to a half. And so this is going to stretch the graph of f of x horizontally by factor 1 divided by 1/2, which is 2. Reflecting is another thing we can do. If we set y to be minus f of x, this will reflect the graph of f around the x-axis. On the other hand, if we set y to be f of minus x, this will reflect the graph of f of x around the y-axis. And so if we take a base case here, y is equal to 1 plus x cubed. First of all, we're going to reflect around the x-axis. So we're going to use the first rule, and so we're going to put a minus sign in front of the function. And so y would be minus 1 minus x cubed, and you see it graphed out here, and it's reflected around the x-axis. On the other hand, if we're going to reflect around the y-axis, we would replace x by minus x in the function, and so y would be 1 minus x cubed. And that's what we see here. In this case, we have a reflection around the y-axis. So in summary, we've talked about vertical and horizontal shifts, scaling, and reflecting functions. We can put all these together and have lots of fun with functions.